everyone. In the previous videos, we showed that how to calculate the one-way Anova table. However, someone may think that the procedure is quite complicated and it is quite time-consuming. Therefore, in the following videos, we'd like to figure out the one-way Anova table by using the Excel file. First of all, we need to open the Excel file and build some settings. And first, we press the File and Options and choose Add-ins. And here we can see that there is an analysis toolpack and the goal, and we need to tick two boxes, including analysis toolpack and analysis toolpack VBA. After that, we can see the data column and we can find a data analysis here. Okay, first of all, if you remember the previous exercise case study 1, we get 3 set of data, and in each data they are including 3 numbers. So now we are going to figure out those data in a following table. So if I set 3 groups here. Okay, in group 1, represent the data in column. For first group of data, it is 1, 2, and 5. And the second set of data is 2, 4, 2. And the third data is 2, 3, and 4. After that, we can choose data analysis for us to analyze and figure out the one-way Anova table. Okay, after press the data analysis, we choose a single factor here and press OK, and we choose the Anova range is from K3 to M5. Okay, and here remember we represent our data by column, so we need to choose column group and check our alpha is greater 0.05. And finally, we choose upper range, and for example, I would like to choose here. Then finalize, we need to press OK. Then here, as we see, this one is exactly the table that I done. Take a look. For column 1, there are 3 numbers, and the average is 2.66, and the variance is 4.33, and so on. We can check. Here is the information of our 3 group of data. And the following table is the one-way Anova table, which include the information between the group and within the group. And here is the total. For this one is SSB and this one is SSW, and we know that SST is equal to SSB plus SSW. And this one is the degree of freedom column, and the 2 here, it is represent there are 3 groups of data, and we minus 1 simply get 2, and in each group of data there are 3 data. So if I would like to minus 1, that will be 2, and since there are totally 3 groups, therefore we totally get 6 degree of freedom within the groups. And here total is 2 plus 6 equal to 8. And here is the MSB, and here is the MSW, and here is the F test statistic, which is equal to MSB over MSW. And here is the F critical region. If we check the F table with alpha equal to 0.05, and we can see that F26, the number will be 5.14. If we compare the F value here, and we can note that the F test statistic is less than the F critical value. Therefore, we could not reject the null hypothesis, which means the mu1 is equal to mu2 equal to mu3, and which also means there is no significant difference within three groups. Okay, let's see one more example. And if you remember, this one will be the exercise 2. And we use the about table and show those data to test the research hypothesis of a difference in the mean isofavor level for the three categories, and we use alpha equal to 0.05. First of all, we get three set of data, and now we need to classify whether those data it is represented by column or row. So now we know that it is represented by representing rows. So when we do the data analysis, we need to careful that since we have we need to choose the column and rows. Okay, now I'm going to do the one-way Anova table, and also again choose data and data analysis, and use the single factor Anova, and choose the input range is 5 to 8, 15 numbers here, and then now we know that our data it is represented by row, so we choose row, and the alpha here say that we need to use alpha equal to 0.05, so alpha is equal to 0.05 here, and take the upper range, and I choose something like that. Okay, and finally press OK, and we can see that in each group of data there are 5 numbers, and we can see the average and the variance. Here is the summary of the table. For the Anova table, here is the SSB, SSW, and SST, and here is the degree of freedoms. Okay, and here we need to know the F test statistic, that is 0.775, which is less than the F critical value 3.88, which is same output with our PVO calculations. So we can conclude that there is no difference in the mean isofavor level for 3 categories.